Okay, we'll look at another way of obtaining a characteristic equation for circle. So this is a third way that you can do it. In this method, we can implement the fact that when a code is given, code AB code is given, you know that if you draw a line to the center of this code, let's call this O. C is the center of AB segment. If we draw a line from the center to the center of AB, you know that these two lines are perpendicular to each other. So OC line is perpendicular to AB line. So this is the property we're going to implement in order to get another characteristic equation for a circle, right? So in this case, let's say that, let me draw this bigger. Right. So now we say the center is given to you, A comma B, and instead of a radius, so in the first case you are given the center and the radius of a circle. So instead of a radius, you are given a point on the circle. You are given now the coordinates of the center and a coordinate, just one coordinate of a point in a circle. Let's say that A, the coordinate of the point A is given as x1 comma y1, right? So I can find a general point on this line. Let's call it x comma y, a general point on this line. So when I find it, I can draw a line segment joining A B. So when I do that, you know, I can also find the coordinate of the center of AP. Given this line segment AP, I can find the coordinates of the center of AP line. So if I draw a line from the center to C, I know that these two are perpendicular. So for this you have to find the coordinates of C. So how do you find the coordinates of C? Given two coordinates, the x coordinate would be the average of these two, so x plus x1 divided by 2, and the y coordinates would be average of these two, y plus y1 divided by 2. So this is the coordinate of C. So here O, right? So we can use the fact that OC is perpendicular to AP. When these two lines are perpendicular to each other, you know that the product of the gradients MOC, which means the gradient of OC multiplied by gradient of AP is equal to -1. Again, we're going to use this fact like we use in the second case. So MOC, how do you find the gradient of MOC? This is MOC, this is MAP. MOC can be found it can be found like this: MOC y plus y1 divided by 2 minus b. So we're gonna use these two coordinates points to find the gradient. y1 plus y plus y1 divided by 2 minus b, difference in y coordinates, and difference in x coordinates, x plus x1 divided by 2 minus a. So you get MOC, gradient of OC line segment. This should be multiplied by the gradient of AP. So let me just make y the subject here. So y minus y1 divided by x minus x1, right? This is the gradient of AP line segment. So the product of these two is equal to -1. Okay, so I will simplify this more, then I will get y plus y1 minus 2b divided by x plus x1 minus 2a, y minus y1 divided by x minus x1 is equal to -1. This is also a characteristic equation, but you can simplify this more if you like. So I'm gonna cross multiply y plus y1 minus 2b into y minus y1. So I can cross multiply the denominator with the -1 here, then I will take it to the other side, then I will get plus this is going to be a long expression, so y plus y1 minus 2b into y minus y1. So I have multiplied these two expression here, plus y plus, because I'm going to take the expression on the right side to the left side, so the minus sign becomes plus sign, x plus x1 minus 2a into x minus x1 is equal to 0. Right? This is another way of obtaining a characteristic equation to a circle. So using this equation, you know that x1, y1, a and b, they are all given. Right? They are all data in the equation. Y and x are to be found. So this equation will give you all the x comma y coordinates, which lie in this circle. Okay, thank you.